Alright, so this is lesson 19 of Python for data analysis. This is our second to last lesson, and today we're going to be talking about classes and modules. So let's start out as usual. Let's go to the lessons folder and go down here to lesson 19, modules and classes. So we'll click on that raw link, copy the URL, and go to terminal, and we're going to change into our lessons folder and then do curl-O or wget, the name of that, paste that link there and download it. And then we're going to source activate or conda activate if you're using Windows, Python 3, and then open up Jupyter Notebook. Alright, so we're going to get lesson 19. Okay, so there's some readings here listed, and then we have our table of contents. So today we're going to cover modules, classes, some object-oriented nomenclature, inheritance and composition, and coding style, including this PEP 8 standard. And we'll also do some, I have some extra examples of classes that we'll see. So first I'm going to make my menu bar go away here, my toolbar header go away. Okay, so we've been using modules during the course, but we haven't really talked so much about what they are specifically. So a module is a file that contains Python definitions, statements, functions. Basically, any .py file can be a module. Any Python file can be a module if you import it to your code. So for that file, we're going to give it a suffix .py, but then when you use it in your code, you'll be importing it. So we'll see some examples of how this works. And just as we've seen with, so for example, we call these things packages, but we can also call them modules. Like pandas is a module, matplotlib, and we import those, and we can import them in different ways. Now these are composed of many different files, but the simplest module could be just a single Python file. And we'll see in examples how simple this can be. And so you can import them in different ways. So we can go to a text editor, and we can copy this text. And so let's go ahead and do that. So we can just copy this text, and then we can open up Sublime Text here, and then we can paste the text here. And so then we want to save this as fibbo.py in the current directory. So I'm going to type Command S, that'll save. Go to our SIO 209 lessons folder. You got to find this. It should be. You can also go up to your home, and then it should be SIO 209 lessons, and then we're going to call this fibbo.py. So what we did is this is just the first thing we're doing here. We're going to copy this text. I could have copied this comment line here. I guess I can go ahead and do that to this text file. And what this is a Python file, but it only has functions. So if we ran this on the command line, for example, it wouldn't do anything, right? It would just define these two functions, and then end and exit. So what these functions do is it generates a Fibonacci series, which is the sum of the two previous numbers in a series, up to the number of elements that we give it. So that n is the number of elements in that list. And we just created the same. We created basically two different versions of the same function. They do the same thing, but this one prints and this one returns the result. So when we want to then use this function, we import this module. And the name of the module is just the name of that Python file without the .py after it. So we've done this. If we go back to our terminal, in fact, I can do this. I'm going to open up another tab. And since I opened up a new tab, you can see that I don't have I'm not in any environment, so I need to activate the Python 3 environment in this new tab. And then I need to also change to the lessons folder. And then if I look at the files in this folder, I should see fibo.py that we just created there. And I can even look at it with less just to make sure. There it is. So what I'm going to do is follow along with the tutorial here and open up IPython or Python. These three greater than symbols that signifies a Python prompt. So we can just do Python. We could do IPython also, but we'll just do Python. So I'm running Python 3.7, and so I'm going to import Fibo. Now I've imported that module, and now I'm going to type fibo.fib and then 1000, and I get this function. So what we did was we created this file that has these two functions. We imported that, and when we import Fibo, we now have all of the functions and also variables or anything that's defined in Fibo is now able to be used in our code, in our current session. So this is really a classic example of object-oriented programming, where these two functions that exist in this file that we imported are now accessible to us from the Python prompt. So we can also do the same thing. So this printed, because of the way we wrote this function, we calculated these first elements of the Fibonacci sequence up to 1000. So if this last one, if we went beyond that, it'd be over 1000. So that while loop ended. So it's not critical how this while loop works. You can look at it and figure that out. But the critical thing is that here it's printing the results. In this second example, it's actually returning a result. So this is more powerful because we can now save this as another variable. So we can type fibo.fib2. We'll do 100 this time. And now it's giving us a list. So we could say, just like we do in any other Python example, we could say x equals fibo.fib2 100. And now we have x. And so if we do type x, should be a list, right? Whereas if we do, yeah, so that gives us a really handy way to use this function that we created and to produce some output. So this is a very simple example of how you could create your own module. So that there's some other attributes that module has. So one of them is name. So there's the name. There's some other attributes that that modules have. Another thing we can do is we could, if we wanted to use this function a lot, we can do this kind of command here where we can say fib equals fib0.fib, and now we can do fib 500, and now this function has now been kind of assigned to a local variable that we can now use. But another way that we can do this is, so let's try this with IPython. We're going to exit out of Python and type IPython. So now we're still using the same version of Python, but we now have the IPython prompt. So and we're still in that same working directory. So we could do, instead of, if we try to type fib0 now, we just see this file, but we can't use the function. So we're going to do from fib0 import fib2, and now we can have these functions directly in our namespace. So we could say fib20 or fib220, and we're going to get those available to us. We could also have done from fib0 import all. That'll import everything from fib0. Or we've seen this one a lot, import fib0 as fib. This is where you import a module as something else. So you give it a shorthand name. Say we do that a lot with matplotlib.pyplot, right? That's a module within a module, and we want to just name that whole thing as one short thing as PLT. Makes it much easier to write code. So that's the kind of thing we can do here. Or we can even import a single, here we have a single function, and we're renaming it. We're importing one function and renaming it all in the same command. So you can get quite fancy with this. These are sort of more common, but depending on whether you want the everything in the current namespace or you want to use it more in an object-oriented way is up to you. Question? Yeah.
Sorry, this is a basic question.
Mm-hmm.
When you're in your terminal and you after you've activated the environment, why is it not in Python already? Why do you have to say Python to make that? You just activate your Python 3 environment,
Mm-hmm.
and you try to do the import thing.
Yep.
It doesn't work.
Right.
Because you have to do the Python first.
Yep. So the question is, why do we need to actually type IPython or Python? So even though we already activated this environment. So when you activate the environment, all you're doing is defining your path variable. Basically, you're defining where your computer is going to look for commands and then packages and things when you type a command. But it doesn't actually enter you into Python itself. It just gives you access to a certain version of Python with certain dependencies and packages that are available to it. So if you can, we call this environment Python 3, but that's just, we could have called it Bob 2000 or something, right? it would have been a lot cooler, and we probably would have had more fun this quarter if we'd done that. But I just called it Python 3, so it's clear that this is a Python 3 environment. But you can call it anything. In fact, if you look at, so if I look at my conda and list, I've got this Chime 2 environment. I've got this environment I use for writing papers that has some certain packages. I have this package I use for EMP, and this is a Python 3 version of that environment, so it's EMP-py3. These are just different environments, but I don't have to use Python when I'm using them, right? I can do anything on my computer. Just so happens that those have certain versions. In fact, these packages some of these have different versions of Python. So that kind of, hopefully that answers your question. So if you want to, if we were to type, let's see what happens if we type. So first of all, let's do ls. Well, you can do ls lrt tail. And what you'll see here is we created this directory pycache. So if we go into that, we've created this. I'll take a quick look. There's a command called file. This data file that basically creates a cached record of the data that's in that Python file. So let's go back to where we were, back to our lessons folder. But if you want to, if we just do Python fibbo.py, as I said, you're not going to get any output because it just has those two functions. But it is possible to turn that script into a script that can take arguments as well. So this is a module that could be run either, as we've just seen it, from either a command line or a. So the other thing I should point out is, let me just add this here because this I think is going to be useful. So we can also do what is it? Oh, right. Does anybody know why I got that error? Yeah, because I needed to. I didn't do import from fibbo import star. I just did import fibbo. So right. So all we're doing here, and the cool thing about the notebook is we have this handy. You have this also in IPython. This handy tab menu. When you type tab, it tells you, oh, here are the two functions. So let's do that. I can even see what it does. I didn't specify a doc string, so it doesn't really tell me much about it. But still, I can run that function, and this one prints, and this one generates a list, just like in the terminal. Okay, so if we now want to take this this script that we made and make it, or this module that we made and make it double as a script, right? So if we think of a module as this thing that we import and we use it from another piece of code or a notebook, whereas a script is something that you can run directly from the command line. What if you wanted to have it to be able to do both? So what we can do is we're going to say, we're going to add this thing where this special variable is called name, and if name is equivalent to main, which will happen when we run it from the command line, it will take we will import the sys module, which allows us to use the argument style of passing arguments to a function. So let's do that. We're going to copy that. We're going to go back to our text editor, and we're going to copy this to the end of the file, to the end of the module, and then save. So now, let's go back here. Now we can type Python Fibo 50, and now it works. So what it did was it realized that we were running this from the command line, and so it executed this block, and then it basically says run the fib function on an integer of whatever we put in as our first argument, which is this number 50. So when this is run, this 50 is read in as a string, because it's a command line argument. It's read in as a string, so we have to convert it to an integer and then run the fib function. So that's pretty cool. If we then go back to IPython and import Fibo, that nothing is run. It doesn't think about this block because it wasn't used it on the command line. So we can still do things like Fibo and these various functions. Again, just like in the notebook, when we use IPython, we also get this handy tab menu. And so, as it says here, you can use this, as we just did, to create a convenient user interface to a module, or to test the code to make sure that it runs the way you want it to before you incorporate it into your code. Packages are kind of just a different name for modules. This is a way of using multiple modules together, and modules that are submodules of parent modules. So if we did A.B, this would signify that we had a submodule B that was in a package named A. And so this allows us to that the submodule has variables and things that are defined that are not recognized by other submodules or by the parent module, so that you can collaborate, for example, on a big project and not have to worry about what someone else called their variable on this other part of the package. So we've seen this example when we import PyPlot. PyPlot is just a part of Matplotlib, a very important and central part, but not the whole thing. And so we were only using PyPlot, so we used this submodule and imported that as its own kind of module.